Dear students, welcome to our class on JRF, SRF, Net 2022 to latest general knowledge. So far we tried to understand in the latest general knowledge different crops, their productivity. Similarly, in case of horticulture class, we tried to understand so many things. Later on, we tried to a greater extent on livestock production and achievements in the livestock production. Then in today's class, fisheries and aquaculture production. So unless we supplement the food requirements with the fish and aquaculture systems, there is a danger that for food security we are missing an important aspect of food security item, that is fisheries and aquaculture. In this class we try to understand what are the fisheries and what are the achievements in fisheries, what are the achievements in the aquaculture, what is the way forward, and from now onwards we try to concentrate more on food security in the classes to come, latest technology. Now, so in that direction, achievements in fisheries and aquaculture is very, very important. Now, see, the first point in the achievements in fisheries and aquaculture is during 2018-19, the fisheries sector contributed as much as rupees 2,100 billion to the national gross value added GVA, okay, which accounted for 7.3% of the GVA of agriculture and allied sector and 1.3% of the total GVA in 2018 and 19. Once again, for your academic interest, I read very slowly. During 2018-19, the fisheries sector contributed as much as 2,100 billion rupees to the national gross value added GVA. This is accounted for 7.3% of the GVA of agriculture and allied sectors and 1.3% of the total GVA in 2018 and 19. That much is the contributed amount from fisheries and aquaculture. Now, estimates show that the sector grew at a rate close to 11%. The sector grew at a rate close to 11% over the last decade, surpassing most other subsectors of agriculture. See, there are several subsectors in agriculture. Of them, the fisheries and aquaculture systems have contributed enormously, not only for food security but also for GVA. Now, in the post-independent era, the India presently holds the distinction of being the fourth largest in capture fisheries. India stands fourth largest in capture fisheries and second largest producer in aquaculture in the world. Second largest in the aquaculture in the world. For your academic interest, once again I repeat these places that Indian fisheries and aquaculture achieved. Number one is India presently holds the distinction of being the fourth largest in capture fisheries, fourth largest in capture fisheries and second largest producer in aquaculture in the world. So the India's total fish production during 2019-20 stands at 14 million tons, which is about 7.6% of the total global fish production. Okay, once again for your academic interest, in the year 2019-20, India produced 14 million tons, 14 million tons, which is about 7.6% of the total global fish production. Now, fish products also earn considerable foreign exchange for the country worth over 6.70 billion. Foreign exchange 6.7 billion. So imagine the contribution of this subsector of agriculture to the food security and to the foreign exchange. Now, milestones in marine capture fisheries research. Milestone in marine capture fisheries. 1948, first attempt towards scientific estimation of marine fish catch. 1957-58, first marine fisheries census was carried out. 1970, first major attempt to estimate potential yield of fishery resources in the Indian Ocean. 1992, tuna longlining became a established method for fishing for deep sea fisheries. 2016, energy efficient green fishing vessel PV Sagar Harita was launched. 2021, stock assessment of 67 stocks of marine finfish and shellfish was carried out. So these are the major achievements or milestones in marine capture fisheries. Marine capture fisheries. As far as inland fisheries are concerned, we try to understand some milestones. Before that, an important point from your examination point of view, I would like to share with you is the country's inland water resources include 29,000 kilometers of rivers, 0.3 million hectares of estuaries, 0.19 million hectares of backwaters and lagoons, 3.5 million hectares of reservoirs, 0.5 million hectares of floodplain wetlands, and 0.72 million hectares of upland lakes, which annually contribute 1.3 million tons of fish. This is with reference to inland fisheries. I repeat once again for your academic interest, the country's inland water resources include 29,000 kgs of the kilometers of rivers, 0.19 million hectares of backwaters and lagoons, 3.5 million hectares of reservoirs, 0.5 million hectares of floodplain wetlands, and 0.72 million hectares of upland lakes, which annually contribute 1.3 million tons of fish. So this is with reference to inland fisheries. The milestones in the inland fisheries include 1957-61, inventory of all fishing villages along the Ganga and Yamuna Tapati rivers. 1978, initiation of environmental pollution research, heavy metals and pesticides detection in rivers. 1990 to 2010, that means for a period of 20 long years, adoption of culture-based fisheries in reservoirs. 2002, GIS mapping of inland water bodies. 2010-2020, ecosystem-based integrated wetland fisheries management. 2012 to 2021, cage culture demonstration in reservoirs across the country. These are the milestones with reference to inland fisheries research. Earlier we tried to understand milestones in marine capture fisheries. Now these are the milestones in the inland fisheries. Then let us go slowly to development in aquaculture. This is with reference to fisheries. Fisheries and aquaculture are simultaneous, they go side by side. Now, development of aquaculture, these are the milestones. First, the milestones in freshwater aquaculture research. Freshwater aquaculture research. Through this research only, India became self-sufficient in the food security supplied by subsectors of main agriculture. Now, milestones in freshwater aquaculture research include 1959, grass carp and silver carp were introduced in India from Hong Kong. 1967, development of package of practices of sewage fed fish culture. 1970, development of package of practices of paddy cum fish culture. 1970, standardization of composite fish culture through AICRP, All India Coordinated Research Projects. 1970s, standardization of composite fish culture through AICRP on fisheries and aquaculture, development of a package of practices of integrated fish farming in the year 1980, 1994, intensive carp culture technology with a production level of 15 tons per hectare per year developed. 2000 to 2010, technology development of breeding was taking place in a very bigger way. Now, what are the milestones in brackish water aquaculture research? These are the milestones, just 5 to 6 important milestones I would like to share with you with reference to milestones in brackish water aquaculture research. 1975, breeding and larval rearing of shrimps. 1984, in vitro fertilization of egg and seed production. 1987, scientific shrimp farming. 1997, hatchery technology for sea bass breeding and seed production standardized. 2016, biofloc based nursery and grow out shrimp farming technology developed. 2021, captive breeding and seed production of grey mullet and mangrove red snapper. These are the milestones with reference to brackish water. Similarly, milestones in mariculture research. There is a wonderful progress in the mariculture research. Just 4 I would like to share with you milestones. 1964, seaweed culture experiment was first initiated on Gujarat coast. 1974, standardization of culture techniques of agri yielding seaweeds. 2007, sea cage farming started with sea bass. 2010-21, breeding and seed production of sea bream. These are the milestones in mariculture research. Now, what is the knowledge gap? What is the way forward as far as fisheries technology is concerned? This is the last topic for today's discussion: knowledge gap and way forward. Now, see, as I said in the beginning of this class, food security and nutritional security is one of the major challenges of the present era. In future, there should not be and must not be any slacking efforts, or there must not be any scope for leisure technologies for food securities. So one should go with a clear vision, okay, direction, with a clear vision direction. In that aspect, marine aquaculture, these are the important fisheries, and aquaculture are the most important sectors that would contribute immensely, not only for food security and nutrition security, but also with reference to foreign exchange. Now here, in the knowledge gaps and way forward, we try to just enlighten ourselves with 5 to 6 important points. One of the greatest concerns for India in 21st century is food and nutrition security for a predicted population of 1.6 billion by 2050. The fishery production system that could contribute significantly to future food production are increasingly under pressure due to rapid resource degradation as a result of anthropogenic activities, including pollution from land-based resources, climate change, etc. Overfishing and excessive juvenile catching are triggered by economic and social compulsions. Any increase in marine output should come from offshore fisheries. Climate change research, their effect and current mitigation strategies should be assessed, and appropriate technologies or interventions based on forecasts should be developed and changed as needed or desired. Through numerous technologies, of course, even though numerous technologies were developed, okay, across the diverse domains in fisheries and aquaculture systems, for greater adaptation at the ground level, better integration of technologies as well as collaboration with other organizations and departments are most essential. So these are the points that I would like to share with you as far as knowledge gap and way forward is concerned. Now I thank you immensely for your very patient hearing with reference to initially agriculture. then horticulture, then livestock. Now, slowly we have tried to understand the importance and milestones in fisheries and aquaculture systems. Thanking you very much for your very patient hearing.